All right, so we're going to go ahead and get started. We got a lot of stuff to cover today. We have 4.5 and 4.6. So 4.5 is a lot of review from college algebra, so I'm going to go kind of fast in 4.5. I just want to make sure we get to 4.6 because that is the new stuff, and I want to make sure that we have enough time to cover that. So I think I'll probably skip the practice problems here in 4.5, and then if we have time for them at the end, we'll go back. If we don't have time, I'll just record them tomorrow and post them for you guys, okay? All right, so this first thing that we have here is just a little introduction to zeros. I want you guys to know the associations between zeros and the graph and how they work as factors and everything like that. So if I am taking this function and I want to graph it, I am going to go over here to my graphing calculator and I'm going to put it in. We're going to put in x to the third minus 5x squared plus 2x plus 8, and we're going to graph it. Okay, so we have this nice beautiful graph here, and it's really hard for me to draw the graphs on this thing here, but it looks like we are crossing the x-axis right around here at -1. Again at, let's see, we've got a y, looks like that's at 8, and then another x at 2 and 4. And how did that one move? Okay, so we had a -1 here. We had 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4. So it looks like we came, and this is always really hard to draw with my writing pad here. So we came up here, crossed right here, down, oh, and up again. So something like this. Okay, if we look at the calculator here, we can identify the zeros. You can tell on here, sorry, the x-intercepts. You can tell on here where they are because they're nice even numbers. We can also go second table to look at those. So we see that we have an x-intercept where y is 0 at -1. We see we have another one at 2, 0, and then another one at 4, 0. We also see we have a y-intercept at 0, 8 there. Okay, so remember to find the intercepts, we want to find it algebraically. You plug 0 in for that other value. You can also come on your graph and look at them. So our x-intercepts, we have -1, 0, 2, 0, and 4, 0. And then we had that y-intercept of 0, 8. The domain and range of the function, just for this one here, they're both going to be continuous up and to the right, down and to the left. So both the domain and range here are going to be -infinity to infinity. Oh, that's not going to work. Okay. All right, so then let's say we want to find the indicated values. Okay, so we found the x-intercepts. Now we want to plug values in that were from our x-intercepts, 2, -1, and 4, and see what we get coming out of the graph or the equation here for those values. So if I plugged a 2 into this equation, I would have a 2 cubed minus 5 times 2 squared plus 2 times 2 plus 8. This would give me 2 cubed 8 minus 5 times 2 squared would be 4, so minus 20 plus 4 plus 8. 8 minus 20 gives me a -12. Plus 4 would give me a -8. Plus 8 would give me 0. Okay, so when I plug 2 in, I get 0 as my output. So we say f of 2 equals 0. Say we do the same thing with -1. We have a -1 cubed minus 5 times -1 squared plus 2 times -1 plus 8. -1 cubed is going to give me -1. -1 squared is +1. times negative 5 gives me a negative 5. 2 times negative 1 is negative 2 plus 8. Negative 1 minus 5 is negative 6. Minus 2, negative 8 plus 8, 0. So again, my output is 0. We do the same thing with the value 4. So we have 4 cubed minus 5 times 4 squared plus 2 times 4 plus 8. So we have 4 cubed is going to be 64 minus 5 times 4 squared. I do not know off the top of my head. I think it's 80. Plus 2 times 4, 8 plus 8. 64 minus 80, that's going to give us negative 16. Then we're going to add 8, would be negative 8 plus 8, 0 again. So there, all of our inputs, if we input each of those x-intercepts into the function, then we get an output of 0. Then I want to take these values and put them into a factor, x minus the value. So we have x minus the value 4, x minus negative 1 gives us x plus 1, and then x minus 2. And we multiply these out. Okay, so we could start with doing x minus 4 times x plus 1. So here we would go x times x and get x squared, x times 1 and get x, negative 4 times x, we're going to get a negative 4x, and negative 4 times negative 1, negative 4. This is going to give us, let's see, x squared minus 3x minus 4. Okay, then let's take that and multiply it by the x minus 2. I'm going to take this, put it in parentheses. I'm going to put the x minus 2 in front. So I'm going to take the x, I'm going to distribute it to each value here. So we're going to go x times x squared. So it's going to give me x cubed. X times negative 3x would give me a negative 3x squared. X times negative 4, negative 4x. So I'm basically just tacking on an x to each value in that second parentheses there. Then I'm going to multiply each term by negative 2. So negative 2 times x squared is going to give me a negative 2x squared. I'm going to line them up where they're like terms, just so it's easier for me to combine at the end. So negative 2 times negative 3x gives me a positive 6x, and then negative 2 times negative 4 gives me a positive 8. Then I'm going to combine my like terms. I've got them lined up nicely. So I can bring down a x cubed. Here I have a negative 5x squared plus 2x plus 8. And that's the function I started with. So if I take those zeros or those x-intercepts, I put them into factors, multiply them out, I get back to my function. So that's kind of what we're looking at today with zeros and with constructing functions in 4.6. So I think the end of that is what can we infer from these answers? So we can infer that our x-intercepts are going to equal our zeros of our factor. If we plug our x-intercepts, we should get zeros into the function. And those values are going to give us our factors. Okay, which our zeros are our solutions to the function. So the graph can tell us a lot about a function. It gives us our factors, and it gives us our solutions. Okay, so that's just a little preview. Let's go ahead and jump right in here. Let's review a little bit with division. So synthetic division, block division. Okay, you should have covered both in college algebra. So I don't have the steps written out on here because it is review, but the first step would be to fill in any missing zeros. Okay, so here I go x cubed to x. So I am missing an x squared. So that means I've got a 3x cubed. Then I have a 0x squared. Then I have a 2x plus 5 because I want my zeros to go in descending order. So 3, 2, this is x to the first, and then that's our constant. Okay, so fill that in. That's your first step. Okay, then the second step is to set up our synthetic division. So we have here our little division. I call them division pants because they're on the bottom. What do I put in here? Do you guys remember?
The positive 3.
Yes, positive 3. So we're going to take the opposite value of what's inside here because remember, it's the 0 or it's the x-intercept put into the factored form. So another way you could look at that, you could just remember it's the opposite value, but you could say if I set this equal to 0 and solve it, then I would be going like this. So I'm testing the value x equals 3. And then here I'm going to write the coefficients. So I've got a 3, a 0, a -2, and a 5. And then I do my synthetic division part, which is the first thing I do is I bring down my first value, which is a 3. Then I multiply 3 times 3, and I put it right here. So I can draw another arrow here. So that's going to be 9. Then I combine, or I add down this way. So 0 plus 9 would give me 9. And then I repeat. 9 times 3 gives me 27. -2 plus 27 gives me a positive 25. 25 times 3 gives me 75. 5 plus 75 gives me 80. If I don't have a 0 as my last value there, then I say, okay, 3 is not a 0 of the problem, but I can still do the division. I just have a remainder. So that's my remainder there. So do we remember what we put for our variables? We would start with x squared, yes. So 1 degree down. So we started with x cubed. So here we go 1 degree down. So this would be x squared. This would be x. This would be our constant. And then our remainder is 80. And we don't write our 80. We put it as plus 80 over x minus 3. So I did put a question or two on the test like this. So if you have a remainder, you have to write the whole remainder out like that. Okay, not just like 80, because then it would mark it wrong. I'm going to go through and check all those on the test, so I would give you the credit back. But just, you know, so you guys are aware, on my math lab, you want to make sure you write the whole remainder out. Okay. Long division. So let's review long division here. So I do have the steps for long division because I know that sometimes, well, this isn't something you guys are going to normally do. So you forget. So you follow the same steps for long division that you do for regular numbers for long division. Just this time, you've got polynomials. So you use long division a lot of the times when you have a number in front of your x, or if it starts with like an x squared or something like that. You can't do synthetic division. So first thing we do, order the dividend from greatest to least by exponent, filling in with 0. So same thing we started with synthetic division. So here, okay, I don't have anything I'm missing, so I don't have to fill anything in here. Okay, then we are going to place the dividend under the long division sign with the divisor. I think it spell checked it out for me. Divisor on the outside. This is your divisor here. So this is going to go, let's see, I'll write it down here. So we've got so 2x minus 3. And then that was plus 3. 6x squared plus 5x minus 10. Okay. So we're set up. So step 3. Take the first term of the dividend, divide that by the first term of the divisor. So that is going to look like this. This is my dividend, 6x squared. So I'm going to go 6x squared. And I'm going to divide that by this first term here, 2x. I'm always going to divide by that first term of the divisor. So I'm always dividing by 2x in this problem. That gives me 6 divided by 2, 3. X squared divided by x, x. So I get 3x. I'm going to put that on top of my division bar. Okay, that's my quotient. So then the next thing I do is I'm going to multiply my quotient and my divisor. So I have 3x times 2x plus 3. So I'm just distributing the 3x. Okay, and then I'm going to put the answer under here. So I have 3x times 2x gives me 6x squared. Then I have 3x times 3, which would give me a 9x, and that's a positive 9x. Okay, so I did 3x times 2x, put that here, 3x times 3. Okay, then, this is the important step, subtract. Okay, so you're changing the signs. So, right here, change signs. And then bring down the next term. So here I would make this subtraction, changing all the signs underneath here. Okay, when you do the subtraction, these should cancel out. Okay, so these guys here, 6x squared minus 6x squared, 0. So that cancels out. And then you have 5x minus 9x gives you a negative 4x. Take this minus 10, bring it down. And then you repeat. Okay, so I would do first term divided by first term again. So negative 4x is my new first term. So I'm starting from this first term down here over 2x, because you're always doing 2x there. Okay, so negative 4 divided by 2 gives me a negative 2. X divided by x, those cancel. So then I put this right here. Okay, then I distribute again. So I do negative 2 times 2x. That's going to give me a 4x. Put that underneath. Then negative 2 times 3 gives me a negative 6. Put that underneath. Okay, then change the signs, which means this could become subtraction, this becomes addition. So, oh, that should have been a negative 4 in the beginning. Sorry, this is negative 4. So this becomes addition, this becomes addition. Sorry about that. Negative 2 times 2x, negative 4x. So then these cancel out. See, and I noticed I did that because when I went to do these, they weren't going to cancel out. They should always cancel out those first two terms. And then I have negative 10 plus 6. That gives me a negative 4, and I have nothing to bring down. So this is my remainder. So then you write your answer the same way we did with synthetic division. So we have 3x minus 2, and then you would have plus a negative 4 over 2x plus 3. All right. So let's do one more example of this, and then we got to get to some of the zeros. Okay, so this one, would we do synthetic division or long division for this one? Synthetic. You can do either one if you want. If you like doing long division, that's fine. I just find that most people don't like doing long division. So yeah, synthetic division because it's just that x plus or minus and your value. Am I missing any zeros? Or any x's? No. Okay, good. So yeah, 3, 2, 1, we're good there. So what's going to go in my division pants? Negative 2, good. So then we've got, let's see, 5, negative 6, negative 28, and 8. All right, so we'll bring down our first term. And we multiply 5 times negative 2, negative 10. That gives us a negative 16. Then multiply negative 16 times negative 2 gives us a positive 32. Negative 28 plus 32 gives us positive 4. 4 times negative 2 gives us negative 8. 8 minus 8 gives us 0. So we get a 0 there, then that means this x plus 2 is a factor, and that negative 2 is a 0 of the function. And then our function would be 5x squared minus 16x plus 4. And if it had a box for the remainder, you just put 0. You don't need to put it over anything. Okay. We're going to skip this part for now, but you guys can do it. And what I'll do is I'll make a video. I don't think we're going to get back to it today, but I'll make a video tomorrow and post it so you guys can go over that on your own. You have extra practice. Let's look at zeros. Just out a little bit. Okay. All right, so zeros are the solutions of the equation, also your x-intercepts of the equation. Okay, so sometimes they're real, and that's when you see them. And then sometimes they're imaginary. Sometimes they're irrational as well. Okay, so imaginary, you're not going to see them on the graph, which means we're not going to cross the x-axis, which means it might be something where it goes like that. So you'd have kind of a curve there. That would be an imaginary 0, and then this would be a real one. The irrational ones would just be like square root of 7, which is an actual number. It's just hard to graph. So it's a long decimal. So let's look at this example here. You can use the graph to start the problem. So here we would take this and go y equals, and we're going to put this in. So we have a negative x to the 4th plus 3x squared plus 4. Okay, and we have two real zeros here, where we cross the x-axis at negative 2 and positive 2. Okay, and we can check that on the table as well. But we also have 2 more zeros, and the reason why I know it has 2 more zeros is because my leading coefficient is x to the 4th. Whatever your leading coefficient is, that's how many zeros you're going to have for your problem, okay, for the exponent. And they're imaginary because I only crossed the x-axis twice. So I'm not going to try and draw this, but it was some, yeah, like McDonald's symbol. You guys can draw it on there, here, because I just can't draw on this program. Okay, so sometimes with the function, you can just factor it and solve. So that's going to be the easiest way to find the zeros for this one. So this one we could factor and find our other zeros. So here, what we could do, first thing I would do is actually take out a negative 1. So I have a positive x to the 4th here. So take out a negative 1, which will give us an x to the 4th minus 3x squared minus 4. And then I can factor that. So if I wanted to factor this, I would split this like a normal factorization. I'm just going to do x squared and x squared instead of x and x because it's x to the 4th. And then we say what multiplies to negative 4 and adds to negative 3. We say that would be negative 4 and positive 1. Negative 4 plus 1, negative 3. Negative 4 times 1, negative 4. And then we solve. So we have x squared minus 4 equals 0, and we have x squared plus 1 equals 0. So those 2's came from here because we would take the 4 and add it. We would get x squared equals 4. Then take the square root of both sides. And that gives us plus or minus 2. So that's where your real zeros came from, square root of 4. But then when you come over here to this x squared plus 1, this is where the imaginary zeros come in. Because here we're going to subtract a 1. We're going to get x squared equals negative 1. Take the square root. What's the square root of negative 1? I. So there you get plus or minus I, which we can't graph because it's not a real number. So we have our zeros. We've got 4 of them, just 2 of them are ones that we can see. So you have 2, -2, I, and -I. And then the thing about the imaginary zeros, because you're taking the square root, they're always going to come in pairs. You're going to have a plus and a minus. All right, I want to give us at least 30 minutes to do 4.6, so that's why I know I'm going fast. I'll slow down when we get to 4.6. I am recording this too, so if you need to go back. Possible zeros, rational zeros theorem. That's all the factors of p, which are your constant. Okay, so p is your constant. Q, that's your leading coefficient. So, for example, this one, my constant is 4 or -4. So all of the factors, and you can just do the positive and negative factors. So you would have plus or minus 1, 2, and 4. Everything that multiplies to 4. And then your leading coefficient is 3. Only thing that multiplies to 3 is 1 and 3. So it would just be plus and minus 1, plus and minus 3. And then you just take that and break those out. Okay, so that means you go like this. You do 1 over 1. So that would be 1. And then 1 over 3, which would be 1/3. So plus or minus 1/3. Then you do the 2 over 1, which would be plus or minus 2. And then 2 over 3, which would be plus or minus 2/3. And then 4 over 1, plus or minus 4. And then 4 over 3, plus or minus 4/3. Now, if you didn't have a graphing calculator, then you could take each of those values and plug them in to try and find a zero. Pain in the butt, right? That's why you want to have a graphing calculator. And then, for example, 2, if your leading coefficient is 1, then it's just the factors of p. So this one would just be the factors of 4. So because they're all over 1, so plus or minus 1, plus or minus 2, plus or minus 4. Okay, so those are all the possible rational zeros. Okay, and let's do another. I'm going to do that one. Maybe I'll do this one. I'm going to skip to example 4. And take you through a harder one. That way we can go to 4.6. All right, so finding the zeros of a function. So remember, the number, the degree on there, that's how many zeros you're going to have. So this one, I'm going to find 4 zeros. That's why I skipped to this one instead of the x cubed. So here I want to list the possible rational zeros. So leading coefficient is 1, so it's just all the factors of 24. Okay, so this is just a step in here. There's a lot here. So what multiplies to 24? You got 1 goes in, let's see, 2, 3, 4, does 4 go into 24? Yep. 5 does not, 6 does, 7, 8, 12, and 24. Okay, now we want to find one of these. Okay, just one. You only need one to start start finding all of your zeros, your steps for zeros. So here you could plug them in algebraically, but again, the easy way is put it in your calculator. So I'm going to put this in my calculator. I've got, let's see, x to the 4th minus 6x squared plus 8x plus 24. And then I go graph. All right, and I can only see 1 0 on here, and it looks like it's -2. Let me check my table. So -2. Does anybody remember from college algebra what happens when you touch the graph and turn around? it has a multiplicity good. So this -2 is probably going to appear more than once on here. Okay, so we've got a 0 of -2. So then once we have 1, 0, what we're doing is we're using synthetic division and we're just reducing it and reducing it until we get to quadratic, and then we use the quadratic formula to solve. Okay, so we're reducing it using synthetic division. That takes you 1 degree down to 3rd degree, and then you would go down from 3rd degree to 2nd degree. Okay, so I take this 0, put it in synthetically. We've got, let's see. Oh, that's probably not going to give me enough room. Let's go over to the side here. I'm just going to do this. All right, so you have a 1. You do not have an x cubed, so be aware of that. So you got a 0. Then we have a -6, x squared. We have a +8, x, and we have a 24. And if you did it correctly, you should not have a remainder when you do this. So first thing I do is bring down my 1. Then 1 times -2 will give me a -2. 0 minus 2, -2. -2 times -2 will give me a +4. Then -6 plus 4 will give me -2. Then -2 times -2 will give me a +4. 8 plus 4 will give me 12. 12 times -2, -24. And here I get 0. Okay, so I have 0, which means I found the correct one. Now I'm going to put this equation in. Well, how I'm going to put that in is this is my x cubed. This is my x squared. This is my x. This is my constant. So I've got x cubed minus 2x squared minus 2x plus 12. I'm going to go back to my graph. I'm going to put this one in. So I've got x cubed minus 2x squared minus 2x plus 12. Go through the graph at -2. Remember, we had that one that touched and turned, which indicated there was a multiplicity. There it is again, -2, so it's appearing twice. So I'm going to take this -2 and I'm just going to do the same thing. So I'm going to put this in now to this 3rd degree equation. So I've got 1, -2, -2, 12. So I'm going to pull down this 1, 1 times -2, or sorry, pull down this 1 times -2. Then -2 minus 2 will give me a -4. -4 times -2 will give me a +8. +6 here. 6 times -2, -12, 0. So now I have a quadratic function. I've got 1x squared minus 4x plus 6. And I can't factor that, so I use the quadratic formula to find the last 2 roots. So let's see here. You guys remember the quadratic formula? Just checking. All right, so you've got -4. So that's going to be +4 plus or minus square root of b squared, so -4 squared minus 4 times 1 times 6 all over 2. Okay, so just in case. Okay, and then let's work that out. So I like to go inside here, get this. So that's a +16 minus 4 times 1 times 6, 24. So that gives me a -8. So I've got, let's see, 4 plus or minus the square root of -8 over 2. Then I have to simplify that. So if I put that in on a test, it's going to be marked wrong on my math lab. I might go in and give you some credit if I look at your work, but we've got to simplify that. So first, take the negative out of the radical. So what I do here is I'll make a plus sign, put an I in front, and then I simplify the radical. So do I have a perfect square that can go into 8? Two and 4, yeah. So here I would go and take this, and I've got square root of 4, square root of 2. That 4 square root of 4 is 2. That comes out of the square root. So then I've got my answer, 4 plus or minus, so this 2 is out of the radical, so it goes like this, 2i, then radical 2 over 2. Okay, so this 2 came right here, this stayed under the radical. Am I done? I could reduce this, right? 4 over 2, 2 over 2. And then this, that's in the radical, so we treat that like a variable, so it's like an x, so don't divide that. But 4 divided by 2 would give me a 2, and then 2 divided by 2 would give me 1. I don't need to write the 1, so just I radical 2. Those are my other two zeros, and I didn't see them because they were imaginary. So my 4 solutions are -2, -2, and then 2. I think you can write them, well, let's break them all out. So 2 plus I radical 2, 2 minus I radical 2. Break them out when you're writing them, unless it indicates that you could not, then you could write it like this, -2 with a multiplicity of 2, because it occurs twice. And then 2 plus or minus I radical 2. So you could write it either way. I'd go the first way. I mean, you're probably writing just as much either way, but I'd go the first way just in case. Question?
This is probably a dumb question, but when we started doing genetic division, why did we continue with -2 instead of switching? We only switched it.
So we find the 0 that goes in to that graph. It just happened that the -2 occurred twice. So let's say I graphed that again and I had a 4 that went through the graph, then I would switch it to the 4. So whatever that 0 is when I come up on it. Okay, so what I'm going to do is I'm going to stop this video here. I'm going to do on my videos, I'll post this one in case you guys need to re-go over it because I went fast. And then I'm going to make it, so that'll be 4.5 part A, and then I'll do 4.5 part B, and I'll go over all these practice problems and stuff so you have more examples. But I want to get to 4.6.